The New York State Department of Transportation is continuing its commitment to improve the Bronx River Parkway for the traveling public. The replacement of 2 Bronx River Parkway bridges, with safety and mobility improvements between East Tremont Avenue and Bronx Park, will be a comprehensive 21st-century replacement and improvement of the East Tremont Avenue Bridge and Viaduct, roadways, shared use path, and the New York City Parks and Recreational Facility and NYPD Highway Patrol Unit facility access. The work will include upgrades to the Bronx Park Greenway and New York City Parks maintenance facilities. The Yonkers AECOM Design Build team understands it will take significant planning, innovative design, and construction methods to execute a successful design build delivery. This assembled team brings the necessary knowledge, skill, and design build experience to execute this challenging project. The Yonkers AECOM Design Build team culture will be rooted in communication, collaboration, and coordination, the 3 C's, with all applicable stakeholders to achieve a successful outcome. The Yonkers AECOM Design Build team will exceed the key project goals for safety, quality, environmental protection, coordination with New York City Transit and third parties, and reducing impacts on the community and local businesses. When completed, the Yonkers AECOM Design Build team will deliver 21st-century performance structures and roadways that are operationally efficient and safer, with improved traffic flow and overhead clearance zones. The team will incorporate innovative design solutions, approved ATC resilient materials, and high-quality construction that will translate into a long service life with minimal maintenance for the department. The Yonkers AECOM Design Build team has developed a design and construction approach that minimizes disruptions to existing traffic, the New York City Transit Service, Operations and Maintenance Facility, New York City Parks and Recreation, and NYPD Highway Patrol Unit 1 facilities. This approach utilizes girder launching and incorporates 5 innovative ATCs to meet the project goals. These 5 ATCs will improve quality of new structures and vertical clearances, reduce structure deadload, facilitate maintenance, and allow for safer steel removal and installation. In particular, ATC 8 greatly simplifies the project by allowing demolition and reconstruction of the structures and approaches in 3 stages, rather than 4 as shown in the RFP. This also improves structural integrity, reduces long-term maintenance, and simplifies work zone traffic and construction over the New York City Transit Yard. 3 blocks of Morris Park Avenue will be resurfaced with asphalt pavement, concrete median islands, and some curb and sidewalks with ADA curb ramps, traffic and pedestrian signals, street lighting and pavement markings from the intersections at East 180th Street to the intersection at Melville Street. 4 additional facilities will be replaced and improved in this project. An improved shared use path will be built to connect existing shared use path at Noble Avenue/Bronx River Avenue intersection to Bronx River Greenway north of the viaduct. The Bronx River Greenway will be upgraded and realigned north of the viaduct, and pavement improvements will be installed in the NYC Parks maintenance yard. Sagamore Street will be extended to the west to provide new access to the NYPD Highway Patrol Unit No. 1 parking lot. Our innovative ATCs offer the following benefits. ATC 8, reduced construction stages. This ATC achieves the demolition of the existing viaduct and bridge and the construction of the new viaduct and bridges in 3 stages rather than 4 stages. This reduces the traffic impacts on BRP, maintaining 3 lanes of northbound and southbound traffic in all stages without cattle chutes during peak travel periods. This ATC eliminates high-risk construction and operations impacts of temporary longitudinal strong backbeams, with substantial temporary foundations and piers in the New York City Transit Rail Yard, Morris Park Avenue, and New York City Department of Parks and Recreation property that would be required to support the west half of the existing viaduct for live traffic when the existing eastern column line and longitudinal girders are removed in the RFP 4-stage construction. The 3-stage construction scheme allows deck and both existing column lines and longitudinal girders to be removed efficiently and productively in a single stage, which results in reduced demolition, schedule, and cost risk. AT C3 Revision 1 Pier 4A. AT C3 Revision 1 Pier 4A, the introduction of the additional permanent Pier 4A in the New York City Transit Yard reduces the length of span 5 from 400 feet to 260 feet, which results in a major reduction in the depth and weight of the girders. The 400-foot RFP span required 11-foot deep girders weighing approximately 1,000 pounds per foot that have massive uplift forces at the south end of Unit 2, at the west end of Pier 3 that required significant counterweight of about 500 cubic yards of concrete encasement. This ATC allows a reduced girder size to 8 foot 6 inches deep and weighing approximately 550 pounds per foot with no counterweight concrete needed. The shallower girder depths also create an additional 2 feet 6 inches of vertical clearance over the New York City Transit Yard and New York City Department of Parks and Recreation properties and New York City streets. AT-C4 HPS-70 steel. This ATC provides greater girder strength and resiliency and reduces long-term maintenance requirements. The HPS-70 steel also assists in reducing the depth and weight of the girders, which will facilitate the girder launching operations. AT-C2 Relocation of the north abutment provides for the new north abutment to be constructed in front of the existing north abutment that will be left substantially in place, reducing demolition noise and debris, trucking, environmental impacts, cost, and schedule. This ATC will allow the sequence of the abutment construction to be done early in the project, with the footing and the stem and wing walls to be built monolithically without stage construction joints, thereby improving quality. AT-C5 AT-C5 Pier 6 relocation. This ATC shifts Pier 6 south by the same distance as the north abutment is shifted south in AT-C2. The length of span 6 is reduced by 12.5 feet, thereby reducing future maintenance over the New York City Transit and New York City Department of Parks and Recreation yards. In Stage 1, the Yonkers AECOM Design Build team will remove existing median and roadside barriers and place temporary pavements required for the Stage 2 work zone lane arrangement. Next, the travel lanes will be relocated to the west and reduce lane width to 10 foot 6 inches. This will provide a 15-foot work zone to begin construction of the eastern section of the bridge. The Yonkers AECOM Design Build team will set up the construction containment areas and establish access in the MTA yard. This will include a chain link fence on top of temporary concrete barrier around the work zone perimeters. Entrance and driveway access will be from 180th Street to transport materials without impacting train operations. The Yonkers AECOM Design Build team will perform construction operations inside the containment area to the greatest extent possible to reduce the need for track outages. Construction at Pier 5 will require direct access for deliveries and crews from the existing viaducts, closed lanes, and stair towers. Parking spaces in the MTA yard for employees will be maintained. Their access from 180th Street for the project duration will be maintained. Stage 2. Work will continue constructing the piers and will be completed in phases that will match the bridge construction scheme. All of the work with the lanes shifted to the west and narrowed to 10-6 is being performed in Stage 2. Excavation and micropiles will be driven at each pier location. Foundations are then poured and piers erected. Next, we will build a portion of the approach roadway, retaining walls and abutment from the Amtrak bridge to the south abutment. This area will be used as the launch bay for the bridge, launching in Stage 2 and 4. On the north end, construct the approach roadway up to and including a portion of the north abutment and retaining wall. 3 to the north abutment, temporary piers will be placed with jack stands and rollers to guide the girder segment. The launch bay will have temporary supports and launch rollers for the first girder assembly. A crane will lift and place girder segments on the rollers for the launch. 4 launch nose girders will be assembled to the leading edge of the launch girder set. Each girder segment will be spliced together with space for rollers to operate unobstructed. The full length of the girder segment will be 450 feet. The segments will be held together by diaphragm. A pair of Enerpac strand jacks will be used to push the assembly using a 19-strand cable anchored at the north abutment wall. We will coordinate with Metropolitan Transit Authority, MTA, and New York City Transit, NYCT, to close down movement on tracks under girder launch zones. The first tracks to close will be 11 through 16 during daytime hours. Once the initial 450-foot girder assembly reaches Pier 5, the team will begin assembling the 575-foot girder assembly behind it and launch both segments together until they reach Pier 3. This innovative approach will eliminate cranes on the MTA properties and reduce impact to New York City subway operations. Once both assemblies have reached Pier 3, they will be lowered onto their final steel plate pads to await deck construction. Avenue. This will be launched just beyond Pier 2. Once the piers are lowered into place, a crane and truck will remove the nose pieces to make way for the final girders to be placed. The final girder set will be set using a crane and spliced together with the previously launched segments. Three lanes of northbound traffic will now be moved to the newly constructed bridge, and the 3 southbound lanes will be moved to the east side of the existing bridge. Stage 3. Work will now shift to the construction of the piles, foundations, and piers that are needed for Stage 3. Also, temporary piers will be used to hold the pier caps until Stage 4 is completed. The launch bay area at the north abutment will be prepared. Assembly and launching of this segment will follow the same sequence as Stage 2. The remainder of the southbound spans will be constructed using conventional method using cranes from the surface streets. Concrete deck surface, barriers, and dry stand pipe system will be installed. Southbound traffic on the existing bridge will now be moved to the newly completed bridge. Stage 4. The existing steel floor beams and girders will be removed with extreme care to ensure stability during demolition. The steel pieces will be cut into smaller pieces for off-site disposal. A mobile gantry crane will be used for removal of the major structural steel components of the existing viaduct. This mobile gantry is comprised of 2 self-propelled mobile transporters, spaced about 60 feet across from each other and connected with engineered gantry steel beams and hoisting equipment. This efficient and innovative equipment will have more than enough capacity to handle the existing main girders that weigh about 900 pounds per foot. The transporter will walk back and repeat the lifting operation span by span unit until all floor beams, girders, and columns are removed. The remaining portions of the piers will be constructed using the same work zones from previous stages. An abutment will be constructed as well as the remaining portions on the south end that includes the bridge over Tremont Avenue. Assembly and launching of this segment will follow the same sequence as Stage 2 and 3. The launch bay area will be prepared at the south abutment area. Assembly and launching of this segment will follow the same sequence as Stage 2. The remaining last span will be built using conventional method and assembled from the new bridge deck. Closure pours and final details are completed to provide the special use path. Final lane striping is completed, and all traffic will now be placed in the final location. The Yonkers AECOM Design Build team has developed an innovative approach that will deliver 21st century improvements to the Bronx River Parkway and surrounding facilities. Our team brings knowledge, skill, and experience necessary to deliver this challenging project and a proven approach that will satisfy stakeholders and exceed the department's goals.